a gentle, poetic journey through one of the universe's deepest riddles, exploring the quiet elegance of symmetry, the drama of disappearance, and the silent echo of what might have been. You drift to the dawn of time, where matter and antimatter were born as perfect opposites. A cosmic mirror forms twin particles spinning in silence. But something breaks the balance, leaving only half the story behind. And in the hush, you ask, where did the other half go? Time falls away. You are floating in a place where time hasn't begun, where space has not yet stretched, where the universe itself still sleeps inside silence. There is no light yet, no shadow, only stillness, a breath not yet drawn, and then something stirs, not loudly, not with thunder, but softly, as if the void itself inhales for the first time. You drift through this first motion, this waking, this becoming, and with it comes heat and motion and birth. The Big Bang is not an explosion, not a burst into space. It is space itself unfolding, stretching like a whisper over vastness yet to come. From this shimmering origin, particles emerge, flickering fast, full of energy, but they do not come alone. Each one is born with a partner, each particle a twin, not identical but opposite, matter and antimatter created together, born from the same spark but facing different directions. You see them now, a proton and its mirror, an electron and its twin, the positron. Like dancers, they swirl through this new, hot world, identical in mass, but their charges pull in reverse. If matter says plus, antimatter says. They do not collide at first. There is too much space, too much heat, too much motion, so they drift, billions of them. Twin particles mirrored in motion, riding the wave of creation. You are in a place of perfect balance. A universe made of equal parts being and unbeing, a poem written in symmetry. Every speck of matter is matched. Every step forward is met by a step in reverse. There is harmony here, silent, radiant, complete, but not for long. The universe is cooling. The seconds tick forward now, slow, heavy seconds that carry weight as the temperature drops. Particles begin to find one another, and when matter meets antimatter, they do not argue. They do not fight. They vanish, not into nothing, but into something new. A flash of light, a photon, energy released from the tension of opposites. You float through these moments, a million disappearances, bright, beautiful, brief, matter and antimatter undoing one another in tiny bursts of light. It's not destruction, it's transformation. Mass giving way to energy, form dissolving into brightness. And you begin to notice something odd. The dance is not every particle finds its twin. Not every antimatter partner returns to the flame. Some particles linger, just a few, for every billion pairs that cancel. One lone matter particle remains just one, but one is enough. That one multiplied across space, survivor of a vanished twin, will become the stars, the dust, the breath in your lungs. You, your body, your planet, your past, everything made of matter owes its existence to that quiet imbalance. You wonder what happened. Why did the symmetry break? What tilted the scale? No one knows for certain. Not yet, but you feel the question linger, curling through time like mist. You drift now into theories, not answers, but gentle ideas. One says the laws of nature are slightly skewed, that when particles decay, they do so with a whisper of preference, a slight lean toward matter, a bias baked into the code of existence. Another says perhaps there were once patches of the universe where antimatter ruled, hidden, distant, out of reach. But if they're out there, we haven't seen them. What we know is that this mirror, this cosmic pairing shattered, and we live in the shards. You return now to that early universe, to the moment when balance faltered. You feel how delicate it was, how a tiny difference in the behavior of fundamental particles could change the fate of all that followed. You float beside quarks and leptons, the building blocks of everything, and their antiparticles, antiquarks, antileptons, the same, but not the same. Somewhere in their interactions, the scale tipped, ever so slightly, not enough to notice at first, but enough to remain. The great mirror cracked, and from that fracture, a future bloomed. You pass now through the age of cooling. The universe is expanding, slowing, settling. Annihilation has mostly ended. There is less fire now, more dark, more structure, and the matter that remains, that lonely fraction that escaped its twin, begins to form atoms, hydrogen, helium, simple, patient elements. They drift together, pulled by gravity's soft hand. You hover above them as they swirl into clouds, into stars, into galaxies, and all of it, the whole cosmos, built from that leftover sliver. A billion galaxies, each filled with light, each born from imbalance. You exhale slowly, because this is the shape of your reality. A universe not built from perfection, but from asymmetry, from a mismatch, from a mystery. You, yourself, are made from what was left behind, the twin of everything you know once existed, equal, opposite, and now gone, vanished into light, not entirely forgotten, but no longer here. Still, you ask, why? Why did this happen? Why you, and not your mirror? Why does matter remain? You drift into laboratories now, quiet places on Earth, where scientists try to recreate the beginning. They build machines that smash particles together at near light speed, hoping to glimpse the missing symmetry. Sometimes they see hints, a slight skew in the decay of a particle, a difference so small it could be nothing or everything. You watch the experiments unfold, the math, the magnets, the long hours waiting for one unexpected flicker, and in that flicker, maybe a clue. But the answer, the true reason, still lies in shadow, not in darkness, just beyond reach. And perhaps that's the gift of it, the question that doesn't resolve, the mirror that reflects only part of the picture. You sit now at the edge of time, watching it all unfold, the twin that never stayed, the half that remains, the light left behind, and as the stars turn slowly above, you begin to feel not loss, but possibility, because what was missing made everything else possible. The absence became the stage. The silence became the story, and the mystery it stays with you. You will return to it again and again, but for now you rest in the wonder, in the knowledge that this universe could have been nothing but light. And yet, here you are, made of particles that survived the mirror's shattering, born from a story only half told, and softly you wonder. You float beside particles and their reflections, electrons and positrons, protons and antipotons, each a mirror image, yet each vanishing when they meet. You listen as scientists search for traces, building machines that hunt for what doesn't want to stay, and softly you wonder, why would something exist only to cancel itself? You begin again, floating through the silence after creation. The fire of the Big Bang has faded, but its echoes remain. Particles spin softly in the cooling dark, Held in a delicate dance, a slow unraveling of light and form, you reach toward one, an electron. It is small, a speck without size, but it holds charge, a whisper of negative. It moves fast, slicing through space like a secret, wrapped in probability. But this electron is not alone. It has a twin, not beside it, not bonded, but mirrored. A positron, same mass, same shape, same spin, but the charge it sings, positive instead. Two sides of a cosmic coin, you follow their paths. Each flies free, each carries its identity with perfect consistency. But when they meet, when particle and antiparticle face one another, they do not embrace. They disappear in a flicker, in a breath, gone, and what remains? Light, photons, bright packets of energy born from the vanishing of form. This is annihilation, a strange word. Cold at first, but you feel the warmth inside it. It isn't destruction. It is conversion. Mass becomes light. Matter and antimatter do not fight. They resolve, not violently, but completely. You hover near a proton, now a heavier particle, composed of smaller parts, quarks bound tightly by a force that does not let go its mirror. The antiproton is made of antiquarks. Same mass, same strength, but opposite charges, opposite signs. They too vanish when joined. And once again, light is left in their place. You pause, because this feels strange. Why create a thing that vanishes so easily? Why give mass to something destined to disappear? And yet, this is the way of the universe. Opposites are not flaws. They are structure. Every fundamental particle has an antiparticle, a reflection, not imagined. Real, and though they cancel, they are necessary. You drift forward through time, to the minds that first imagined this pairing. In the early 20th century, a man named Paul Dirac sits with a pen, not in a laboratory, but in a room of equations. He is quiet, precise. He doesn't search for particles in space. He searches for harmony in math. Dirac tries to unify quantum mechanics with Einstein's special relativity. He builds an equation, beautiful, clean, complete. And from this equation, a surprise appears, a solution not for the electron, but for its mirror, a particle that must exist, equal in mass, opposite in charge. He doesn't call it antimatter yet, but he sees its shape, and with quiet certainty, he writes it down. You float beside this thought, a mathematical whisper that becomes real. Years later, in 1932, the positron is found, not guessed, but seen in a cloud chamber, a place where particles leave trails like dew. A thin streak curves the wrong way in a magnetic field, too light to be a proton, too curved to be an electron. A new particle, a confirmation. Dirac was right. Antimatter exists. You feel the shift in the world, how one idea opens an entire half of the universe. Scientists begin to ask, if there is an antiparticle for every particle, where is the antimatter now? They look to the skies, to cosmic rays, to collisions in space. They build detectors, giant instruments in silence. They wait for positrons, for antiprotons, for the rare signature of something disappearing. You drift through one such experiment. In the vacuum particles smash into one another at unimaginable speed. From the chaos, pairs emerge, sometimes a particle, and the one that wasn't quite. Briefly, they live. Then they cancel, and in that cancellation, a flash, energy, sharp and clear, marking where symmetry once was. This is how we know they're real, not by what they leave behind, but by how they vanish. You listen now to the hum of machines too, the detectors and magnets that cradle these brief lives. Antiparticles do not like to linger. In a world made of matter, they meet their ends quickly. To keep them alive, we must isolate them, trap them with magnetic fields, cool them, coax them. Even then they escape. You watch scientists build these traps. Inside them, antihydrogen is formed an antiproton and a positron, together, a ghost of the familiar, hydrogen's mirror. But it cannot touch the walls. If it does, it meets matter, and it goes. So they hold it in fields, carefully, briefly, milliseconds of existence, then light. You imagine this, a star made of antimatter, an entire sun shining with reverse particles. It would look the same, its light, its gravity, all identical, until it touched regular matter. Then a storm, an eruption, pure energy unleashed from every contact. But we don't see those storms in the cosmos. No signs of antimatter stars or antimatter galaxies. Only this world of matter unopposed. And so we wonder, if every particle has a twin, why are the twins missing? You return to the annihilation, to the electron and positron. You watch them. Again, two curves approaching. A tiny flash. A photon born. The mass is not lost. It has transformed. You remember Einstein's equation. E equals mc. Mass becomes energy. It doesn't vanish, but it changes form. Still, you ask, why give birth to a particle that ends the moment it connects? And the answer comes gently, because the dance matters, because creation is a balance, and even the things that vanish leave their signature in what remains. Antimatter shows us that opposites are fundamental, that nothing exists in isolation, that what is only matters in contrast with what is not. You drift back now, past the machines, past the data, to the idea again that these particles, each one with a twin, represent a symmetry, perfect, beautiful, vulnerable, and perhaps it is in that vulnerability that something more is born. You rest beside a positron, caught briefly in a trap. It spins, soft and invisible. Waiting, you know its end will come. But still, it is. It has mass, it has charge, it has presence. And in its existence, however brief, you feel wonder. Because not everything that ends is wasted. Some things shine brighter precisely because they vanish. The positron meets its partner. A quiet moment. A soft pulse of light gone, but the light remains. Energy still moving, still part of the story. You realize now, the question is not why. It vanishes. The question is what it tells us about the way the universe works, about balance, about the cost of structure, about how something can exist only through the possibility of not existing. And so, you float again, back through the mirror, back through the silence, back through the twin particles that come and go and come again. And you wonder. You walk through quiet chambers deep underground, where detectors wait for particles that almost never arrive. A flash of light here, a ripple there. You learn how we search for antimatter not by seeing it, but by noticing its absence. And you ask, is the universe hiding something in plain sight? The world above is bright and loud. Cars hum, birds rise, wind brushes through branches. But far beneath your feet, in a place made of stone and silence, there is a room that listens for ghosts. You descend now, not quickly, no. This journey is slow, deliberate. a staircase spiraling into the earth, where noise and light thin out like fading breath. Down here, beneath mountains, beneath cities, beneath the echoes of surface life, scientists have built chambers of stillness, not empty, prepared. Because to catch a ghost, you must make the world forget itself. You arrive in a cold tunnel. The walls are smooth. The air hums faintly with electricity, but mostly there is quiet. You are in a particle detector, not a net, not a cage, but a patient observer, built not to grab, but to notice. Because the thing we search for, antimatter, is shy. It doesn't linger. It doesn't shout. It appears in flickers, in flashes, in the sudden bloom of light, when something touches what shouldn't exist. You walk slowly past the chambers. One glows with liquid argon. Another, a tank of heavy water. Another, filled with gas. Its wires strung like the strings of a harp waiting for the air to change. Each one listens for something rare, something small. You pass a wall of sensors, metal strips and wires so fine you could mistake them for spider silk, but they are tuned to a single moment, when a particle moves through their field and leaves behind a whisper of its presence. This is not vision. It's inference to see the invisible. You must learn to feel its trace. You pause beside a screen. On it, a pattern, a sudden curve, a spark of energy, a trail where none should be, an event, a particle came through, or maybe vanished, perhaps. An antiproton touched the chamber wall, annihilated, released light. The sensors caught it, a story told backward from a ripple. This is how we study what doesn't stay. You float now above Earth. Orbiting it is a device, the Alpha Magnetic Spectrometer, bolted to the side of the International Space Station. It watches cosmic rays, particles from deep space, flying at near-light speed, born in supernovas, black holes, distant explosions. Among the many are a few that curve the wrong way in a magnetic field, too light for protons, too strange for electrons. Antimatter, each one, a traveler from somewhere else, a relic. But are they born in stars, or are they fragments from collisions along the way? We don't know yet. Still, we listen. You drift deeper into time, to the first detectors, cloud chambers, where alcohol vapor curled around particles, revealing their paths. There, in the mist, scientists saw curved tracks that betrayed something unseen, a positive, moving backward, leaving light where there was none. Then came bubble chambers, scintillators, silicon trackers, each one finer, more precise, a more sensitive ear for the quiet footfalls of antimatter. You step into CERN, the great circular collider beneath the French-Swiss border. Here, protons race through tunnels faster than your thoughts. They smash together in controlled violence, and for a brief moment, energy becomes possibility. From that energy, particles emerge, some known, some exotic, some made of antimatter, but they vanish quickly. Before they do, they leave trails, their mass, their charge, their momentum, recorded frame by frame. You hover in one of those frames. A collision, a spray of forms, curves bending to the left and right, depending on charge. From these curves, scientists rebuild the moment. They name the particles. They find the ones that shouldn't be there. And sometimes they see a mirror, an antineutron, an antihelium nucleus. Rare, unstable, but real. The detectors hum with patience. They cannot grab antimatter, but they catch its echo. They wait, sometimes for years, for a single flash. You stand with the scientists. You watch them sift through oceans of data. Most of it is noise, known patterns, expected outcomes, but every now and then something odd, a signal that does not belong. They do not shout, they test, they confirm, they doubt, because ghosts are tricky. Background radiation, instrument error. Even a speck of dust can pretend to be something profound. So they wait. They check again. Truth here is not a discovery. It is a narrowing, noticing what remains after everything explainable has been explained. You rest beside one such result. Positron excess. More than expected. More than models predicted. Is it dark matter colliding, or a nearby pulsar, or something else? We don't know, but the question opens the sky. You float now toward Earth's atmosphere. Cosmic rays strike air molecules, shattering into cascades. Among the debris, muons, pions, positrons, antimatter, brief and fragile. The detectors below try to capture the timing, the shape of the shower, the energy that fell from space. We build maps of these interactions. We sketch the heavens from the ashes of invisible collisions. And still, we have not found an antimatter galaxy, not one. Not a single region glowing with the light of opposite matter. If such places exist, they are far hidden behind the glare of ordinary stars, or perhaps they never were. Still, we search, not for proof, but for possibility, because to find just one atom of antihelium from space, just one, would rewrite our story. It would mean a piece of the lost. Twin survived, so we wait. You return to the chamber beneath the mountain. The detector sleeps, but it is never off. It listens always, like a lake waiting for a single drop. And you understand now, we do not need to catch the ghost. We only need to notice when the world bends around its passing. You close your eyes, you feel the presence of what has always been there, unseen but not absent. Antimatter is not imaginary. It is simply rare, quiet, slippery, but with every ripple, every trail, every echo, we learn more, not about just what is, but what was, and what might still be. You breathe in that thought. The idea that the universe is full of things not easily seen, that sometimes what matters most leaves only a whisper. We do not always need to see directly. We can know through reflection, through response, like a wind in the trees that shows itself by the way the leaves move, or a memory that returns not as a picture, but as a feeling. Antimatter passes through us, not always touching, but always part of the whole. And softly, as the detectors continue their long wait, you begin to ask. In the beginning, there was symmetry, not just balance, but the kind of symmetry that feels like a promise, a whisper from the universe that things are whole. You drift into this symmetry now, not through numbers or rules, but through feeling. Imagine a dancer turning in place, every motion matched by a spin, a step, a pause, and every time, the world answers in kind. This is the language the universe speaks at its most fundamental. Symmetry is not decoration, it is structure. Everything at its root follows rules, not laws imposed from above, but agreements woven into the threads of being. When a particle spins one way, another spins the opposite. When one moves forward in time, its mirror could be imagined moving backward. When one carries charge, its partner carries the opposite. You are surrounded by these pairings. Though you don't see them, they happen in silence, in fields, in equations. But they are real. They are everywhere. Symmetry gives rise to conservation. the quiet laws that keep things steady. Energy is never created or destroyed. Momentum is preserved. Charge remains balanced, like a playground seesaw in perfect stillness. Up and down held in quiet trust. You hover beside a simple particle, perhaps a muon. It spins gently, and you feel the symmetry in that spin, a mirror. Image would spin in the opposite direction. Its behavior, its decay, its traces would reflect perfectly, unless something is broken, and sometimes something is. The universe is not entirely symmetrical. You feel this not as a flaw, but as a tension, like a held breath, because somewhere, in the fabric of all this order, something leans just slightly, barely, but enough. You drift into history. To the 1950s, where two physicists, Song Dao Li and Chuning Yang, question a long-held assumption. They ask, does the universe really treat left and right the same? Is parity, mirror symmetry, truly sacred? It had always been assumed. Everything else seemed balanced. Surely this was too. But they look closer. They ask a colleague, Chen Xiongwu, to test it. And she does. She takes cobalt atoms. She cools them, aligns them, watches their decays, and finds they are not symmetrical. The electrons emitted prefer one direction. The mirror is broken. Parity, once trusted, is not absolute. You feel the quiet quake of that discovery. Asymmetry, something once invisible because it was assumed, has been exposed. And it isn't perfect. This is the first crack. Later, scientists find that another symmetry, called CP charge and parity combined, is also broken in certain decays of kaons particles made of quarks. There is a preference, a lean. The matter does not behave as its antimatter twin should. Even together, the symmetry doesn't hold. You pause beside this idea. You look at the kaon, at its mirror, and realize they are not exact reflections. The dance isn't perfectly mirrored. The spin stumbles, just slightly, and from that stumble comes the world, you know. Because if CP symmetry were perfect, matter and antimatter would have cancelled completely. The early universe would have vanished into photons. No stars, no atoms, no breath. But because the mirror cracked, a few more matter particles remained. The imbalance is tiny, perhaps one extra matter particle for every billion. Matter pairs, but it was enough. That sliver of survival built everything your mind. The stars in the sky. Symmetry's secret is that it doesn't need to be perfect to be powerful. You return to the patterns now. The standard model, our best theory of particles and forces, is built on symmetry. It arranges particles into families, balances, charges, predicts outcomes. It is elegant, but even this model admits its own imperfections. It doesn't explain all the asymmetry. It doesn't account for why so little antimatter remains. It tells part of the story, but not the end. And so, you step into deeper waters, theories beyond the standard model whisper of hidden symmetries, broken at high energies, supersymmetry, perhaps where every particle has a heavier twin, or leptogenesis, where neutrinos, those ghost-like particles, may hold the key to imbalance. Each theory offers not just answers, but new symmetries, some kept, some shattered. You drift through these ideas, not as facts, but as shapes, as possibilities. Because symmetry is not just a rule, it is a question. Where is the balance? What happens when it breaks? And what is born in the breakage? You feel now the poetry of this truth, that perfection, though beautiful, is sterile. It is in the almost, the nearly, the not quite, that creation takes place. Just as a song needs variation, a canvas needs contrast, the universe needed a flaw, and in that flaw, life emerged. You imagine the early universe again, a place of fury and light, but beneath it all, a whisper of difference, a lean toward matter, a preference so small, but it changed everything. You walk beside the physicists, still searching for that cause. They build experiments to measure CP violation in particles you've never seen, beauty quarks, tau leptons. They seek patterns in the decays of particles that live for less than a blink. They know that the clues lie in the subtle, in the slight delay, the uneven pathway. The asymmetry that matters is not grand. It is delicate, like a single word out of place in a poem, changing its meaning entirely. And so, you wait with them. You sit in the quiet chambers where data accumulates, where millions of events are recorded, sorted, searched, and from these piles of numbers, you begin to see a trend, not certainty, but a hint, a lean. The world has chosen sides, and it has chosen you. You are made of matter. You breathe it. You think with it. You reach with it. But your mirror did not remain, not because it was weaker, not because it was wrong, but because something, somewhere, broke the tie. You exhale. There is sadness in this story, but also a quiet thrill, because the universe is not a machine. It is not perfect. It is a story written with tension, with imbalance, with exceptions. And those exceptions gave rise to everything. You return now to the idea of symmetry, and you look at yourself, your hands left and right, similar but not the same. Your face balanced, but never perfectly. Your heartbeat steady, but irregular in the details. You realize we are built from broken symmetry, from the spaces where the mirror bends, from the small differences that invite change. And you begin to love the flaw, to trust it, to see it not as failure, but as possibility. Just as particles could not have formed stars without imbalance, you could not have formed questions without curiosity. Perfection does not ask, it simply is. But broken symmetry wonders, reaches, becomes. You drift back through time now, to the moment when the last antimatter particle met its end, a flash, a loss, and from that loss, matter remained. Not because it won, but because it was chosen by some quirk of physics we still do not understand. You rest beside that mystery. It does not need solving tonight. It needs only to be held, to be listened to. Because, in that listening, you join the symmetry of thought and wonder. You become part of the pattern, the quiet curve that leans toward meaning. And softly, you ask. You find yourself in a space where time thins, not a room, not a lab, but a moment, suspended. It is here that two tiny travelers meet, a particle and its twin. They've been apart, they've come far, through different paths, through fields and emptiness, drawn now by invisible threads of charge and chance. One is matter, the other antimatter, and in the universe's smallest hush, they find one another. Pause here with them, see the electron, a shimmer of negative charge, moving quick, wrapped in probability. It hums with presence, not of shape, but of effect. And see the positron, its opposite, its mirror, same mass, same hum, but positively charged, as if someone had flipped the universe inside out. They orbit for a moment, like dancers, sensing their final step, and then they meet. What happens next is not destruction, not violence, but conversion. The two particles do not crash. They dissolve. Together, they vanish entirely into light. A photon, or perhaps two, born from their union. This is annihilation. And though the name sounds final, there is something deeply creative in it, because what is left behind is energy. You follow this energy now. As it becomes motion, as it becomes warmth, as it becomes story, for every pair that vanishes, something new begins. You feel that heat on your skin. Sunlight, every warm ray that kisses your cheek, might carry the memory of a meeting like this. Somewhere, a particle and an antiparticle became light, and that light became your warmth. You were touched by 1,000 small disappearances, and so is anything truly lost. You float beside the photon, the child of that annihilation. It moves at the speed of light, no mass, only momentum, only energy, no rest, no pause, just forward. It carries the memory of what once was, the mass of the two particles, transformed, you. Remember the equation E equals mc. Energy equals mass times the square of the speed of light. It tells you this: mass is not a thing. It is a form of energy held still, and when that mass is freed, when it sheds its form, it does not die. It shines. You follow the path of that light. It may strike a surface, warm a leaf, trigger a cell in your eye. It may travel for billions of years through open space, arriving long after its origin has vanished. Each photon is a message, each one a letter from a moment of meeting. And so, when antimatter vanishes, it is not absence, it is becoming. You drift now to the edge of a machine, a particle accelerator inside. Electrons and positrons are steered with magnets, nudged toward collision. They circle, faster and faster, until the moment arrives. Contact, annihilation, out of the silence. New particles emerge, not just light, sometimes something stranger, a morn, a hadron, particles that didn't exist before, born from energy made of nothing but the vanished. This is how we study the subatomic world, not by building it, but by transforming it. We create energy and let it decide what forms to take. You imagine now a room where scientists sit, reading patterns from screens, tracing trails that began in collisions, each trail a history, each spark a whisper of what the world can become when opposites meet. They know this truth. Annihilation is a door, and the universe steps through it. Again and again, you drift outward, toward a star. Here too, in the furnace of fusion, particles meet and transform. Neutrinos born, photons flung. Some of that energy, at some deep point in the cycle, comes from annihilation. Antimatter is rare, but in small moments, in radioactive decay, in cosmic collisions, it appears, and it always ends the same light. You pause beside a burst of gamma rays. High energy, sharp. They come from distant galaxies, from violent births and deaths. Sometimes they come from positrons meeting electrons in the spaces near black holes, where matter is torn and antimatter is briefly made. And so the cycle continues. Annihilation, not as destruction, but as returned mass to energy, form to motion, something to something else. You sit with this thought in your world. We often fear disappearance. We mourn what ends. But in physics, ending is never truly final. Every particle that vanishes leaves behind a different kind of presence, a photon, A wave, a pattern, even absence shapes the field. You touch now the idea of a vacuum, empty yet full. Fluctuations ripple through it. Virtual particles blink into existence, then annihilate. Nothing stays, but everything influences, even the briefest thing has a role to play, and you, watching this dance, begin to feel the rhythm. Nothing is wasted. Even vanishing is generous. Annihilation is not the end of the line. It is a bend in the road where matter and antimatter meet. The universe opens a hand and releases brightness, and that brightness moves on, touching everything. You turn now to your own breath, to your body held together by particles that once came from stars and storms and ancient collisions. Each atom in you a survivor of that asymmetry, but also a participant in this cycle, because deep inside you, in the cells that burn fuel, in the rare reactions of your biology, there are whispers. Of this same exchange, positrons can emerge in radioactive decay. They move, they meet, they vanish into light, and that light adds to the fire of life. You are, in a quiet way, a being woven from the stories of annihilation. You do not see them, you do not feel each one, but their echoes shape you, and now you wonder if the positron disappears, if the electron vanishes, but the energy goes on. Is the story still theirs? Does the photon remember where it came from? Not with words, but with properties, direction, energy, momentum. Yes, it remembers, because nothing is ever quite forgotten. You drift outward again, past stars, past dust, past the quiet hum of galaxies. You reach the edge of visibility. Beyond that, perhaps, some other kind of light travels, the light from annihilations we will never witness, and still they shape the cosmos, a balance, a brightness, a quiet legacy. You return now to the moment again, to particles, one and its twin. You watch them approach. You know what comes, and still you watch, because the miracle is not that they vanish, it's that they ever existed at all, that they found each other, that their meeting left behind something bright, something lasting. You sit with that image, contact, vanishing, light. You hold it gently, and somewhere in that image you ask, close your eyes and float backward again, far, far back, past galaxies blooming, past stars igniting, past the first atoms finding shape. Drift to the moment just after the beginning, the Big Bang, a place of perfect heat and chaos, not a point, but a swelling, not an explosion, but an expansion, everywhere at once, and everywhere filled with light. You arrive in the thick of it. The universe is only microseconds old, and it is full of everything, and its opposite. For every particle and antiparticle, perfect pairs, born from energy itself, electrons and positrons, protons and antiprotons, neutrons and antineutrons, all spun into being in this first searing breath. It is symmetrical at first. Every creation has a mirror, for every presence an equal absence. They dance together briefly, then meet, then vanish into light, annihilation everywhere. Particles and antiparticles turning into photons, into radiant heat. A churn of births and vanishings, a cosmic balancing act on the grandest scale. And yet, after all that vanishing, after the cancelling out of billions upon billions of pairs, something remains, not much. For every billion annihilations, just one particle of matter is left behind. Just one, a sliver, a whisper, but enough. You rest inside that difference now. That small asymmetry, that cosmic preference, 1 in a billion, tiny, but decisive. That one became the seed of all that followed. The leftover matter formed the first protons and neutrons. Those gathered into atomic nuclei. Electrons settled into orbit. Atoms became hydrogen. Hydrogen became clouds. Clouds became stars. The stars forged heavier elements. Those elements built planets, oceans, trees, breath, and now you, all because. The numbers didn't cancel completely. You sit with that thought, quietly, that the world exists, not because symmetry ruled, but because it broke, not wildly, not chaotically, but just enough for matter to win. By a sliver, enough for the universe to keep something. Physicists call this imbalance, baryon, asymmetry. They know it happened, but they don't yet know why. The math predicts that matter, and antimatter, should have annihilated completely. It's elegant, it's expected, and yet here you are, alive, solid. Here the asymmetry must have come early, before seconds passed, before atoms formed, before space cooled. You drift beside a particle physicist now. They are not asleep, but dreaming, in data, in theory, in equations. They try to imagine what could have tilted the balance, what process, what condition, what force or decay could have slightly favored matter. There are rules. Theories like Sakharov conditions lay out what's needed. Interactions that violate baryon number. Processes that break C and CP symmetry. Moments out of thermal equilibrium. A recipe, but not yet a dish. Experiments continue in colliders, in deep space surveys, in the patterns of neutrino oscillations. Physicists study kaons and bemesons, particles that might favor matter just slightly in their decays. They probe the properties of neutrinos, strange, ghostly particles that could hold secrets of asymmetry in their oscillating ways. They explore whether the laws that govern the tiny are not entirely neutral, and yet the answer remains just out of reach. The asymmetry hides, but it leaves its fingerprints everywhere. You look around your room, the floor beneath you, the air you breathe, the warmth of your own pulse, all of it built from matter and nowhere. In any measurable way does antimatter form its own world. There are no antimatter trees, no antimatter galaxies, no twin cosmos lurking just beyond the stars. At least, not that we've found, and so we accept the imbalance, not with satisfaction, but with awe, because it is the reason anything remains. You reflect on how close it came to nothing. If the ratio had been slightly different, if symmetry had won completely, then all matter and antimatter would have vanished into pure radiation. No atoms, no stars, no memory, no question, just light, forever moving outward, carrying no form. Instead, we got structure, we got time, we got the chance to wonder, all from a 1 in a billion difference. You sit now with this number so small, and yet so heavy you feel it in your bones, in the gravity that pulls your body, in the silence between your thoughts. This asymmetry is not a flaw. It is an invitation to ask, to trace back, to imagine what was missed or what tipped the scale. Some believe there may be hidden interactions beyond the standard model, forces or fields that act only in early moments, then fade. Some search for leptogenesis, where neutrinos, the quietest of particles, could have seeded the imbalance through their own strange asymmetries. Some look two grand unified theories where all forces once merged, and symmetry broke in a cascade as the universe cooled. Each of these is a pathway through the fog. Each holds pieces. None yet completes the puzzle, but all of them begin with that sliver of survival, that improbable leftover, that one you trace its legacy. It is in every cell, every heartbeat, every flicker of thought. The balance broke, and from that break, consciousness emerged. You return again to the early universe, a soup of light, a chaos of collisions, and somewhere a tiny tilt, you imagine it, a process favoring matter by the smallest margin, a reaction that leaned just enough, and from that lean, the rest unfolded. You wonder now what the mirror version of this universe would have been. Not antimatter sprinkled into matter, but an entire universe of antimatter, structured, living, maybe even thinking. Could such a place exist, somewhere beyond reach, or did our victory mean its absence? Not war, not conquest, just chance, or rule, or mystery. You hold that curiosity gently, because questions are sometimes more valuable than answers. They keep the light on. They keep the detectors running. They keep the story alive. You are a child of asymmetry. You are what remains, not because the laws of physics favored you, but because the laws allowed a moment of imperfection, and in that moment, possibility took root. The universe is not made only of balance. It is made of slight unbalances that echo forward through time and space. You are one of those echoes, and softly you ask. The room hums softly, not with voices, but with electricity, with magnetism, with the presence of something barely there. You stand at the edge of human precision. Inside this quiet chamber, human hands have built a space to catch the UNCATCHABL ED2. Cradle antimatter, not from the cosmos, not from some ancient accident, but made here. Now, by machines of breathtaking care, you step slowly, as if sound might disturb it. There, within the glowing vacuum chamber, a particle spins, a positron, the antimatter twin of an electron, born from a high-energy event, caught in a trap of fields. It drifts alone, held not by walls, but by invisible hands. Magnetic bottles, scientists call them electromagnetic fields, so delicately arranged that a particle with nowhere to go simply stays. This is not a cage. This is a balance. If the positron touches matter, even the wall, it will vanish. Annihilate, so it floats, suspended, untouched, alive in its strange way. You marvel at this feat. It took us thousands of years to understand particles, decades more to make their opposites, and now we can hold them for seconds, sometimes minutes. In these fragile nests of force, you drift beside the machine that made the positron, a particle accelerator, long and circular, hidden deep underground. It spins particles to unimaginable speeds and brings them into collision. From those high-energy bursts, new particles emerge. Sometimes a pair is born, matter and antimatter, blinking into existence together. From the violence, delicate opposites appear. You follow one such positron as it separated, guided by magnetic fields, into a chamber of stillness. It is slowed, trapped, studied. This is how we know it exists, not by seeing it with eyes, but by listening. For its signs, its spiral in a cloud chamber, its glow in a detector, its annihilation with an electron producing two perfect photons flying away, each signal a whisper of its presence. You are watching the impossible become real. Antimatter, once a theory, a dream, a negative space in an equation, now rests, suspended in a bottle of silence. you begin to understand how delicate this is. Antimatter is not stable in our world, not because it is wrong, but because it has nowhere to stay. The entire visible universe is matter. Walls, floors, atoms, even the air, all made of particles waiting to meet their opposites. So when we make antimatter, we must guard it like fire in a dry forest. One touch and it's gone. Turn now to the antiproton, heavier than the positron. Its twin is the proton, that sturdy core of every atom to make antiprotons. Scientists fire protons into dense targets at incredible speeds. From the chaos, some particles emerge with the opposite charge, opposite spin, mirror images. They are sifted, separated, cooled, held. It is not easy. It is not quick, but it works. And when you pair an antiproton with a positron, they can orbit each other. They can form a structure known as antihydrogen. Yes, the mirror of the simplest atom. A kind of anti-atom. We have made them, we have held them, antihydrogen atoms, floating in traps, surrounded by nothing. They are neutral, no electric charge, so we cannot hold them with electric fields. Alone, instead, we use magnetic tricks, subtle forces to cradle their movement. They drift like tiny stars in vacuum. This is where the wonder grows, because we are no longer just detecting antiparticles. We are building them, shaping them, studying how they fall. Yes, fall at CERN, the European Lab for Particle Physics. Scientists now ask, does antihydrogen fall down at the same rate as hydrogen? In other words, does antimatter feel gravity the way matter does? It should. Every theory says it should. But still, we check. We must. Because, if it doesn't, everything changes. So they build careful traps. Cool the antiatoms. Let them go. Watch. Does it drift down? Does it rise? The results so far say, yes, it falls. Just like you do. But how soft, how strange, that we can even ask. You turn now to the question of use. Can we do something with antimatter? It sounds like fiction. It feels like myth. But the energy from a single annihilation is enormous. A gram of antimatter could release more energy than a nuclear bomb. Imagine that power in medicine, in propulsion, in dreams of deep space. Already, positrons are used in PET scans, medical imaging that lets us look inside the body by following their paths and the light they leave behind. Tiny doses, controlled, safe. But beyond that, to fuel a ship, to light a city, no, not yet, because making antimatter is slow, expensive. To produce just 1 nanogram would cost millions of dollars and months of effort, and storing it even harder. There are no antimatter tanks, no solid forms, just traps, just moments, and still, you wonder. You imagine a spacecraft gliding through the dark, its engines pulsing with the light of controlled annihilation. Pure energy, efficient, clean. The dream is there, like antimatter itself, flickering, almost. Not quite, but possible. You return to the lab. The chamber glows softly. A positron floats still. Scientists record its trace, log its presence, celebrate its brief life. You feel it, the reverence, not fear, not fantasy, just awe. Because here, in the stillness of the lab, we are holding the universe's lost half. We are speaking with the mirror. We are touching the forgotten, even if only for a moment. You walk slowly now, leaving the chamber, the hum fading behind you. But the wonder lingers, because antimatter is no longer just a theory. It is real. It is known. It is held in traps, in beams, in hearts that dare to ask, and softly you ask. The night sky opens above you, wide, ancient, cold, a scattering of stars like frost on dark velvet. You are not looking at the stars tonight. You are looking between them, beyond them, into the black that stretches forever, wondering what might be hiding in plain sight. You think of antimatter, not as a particle in a trap, not as a flicker in a lab, but as a world. Could it be? Could there be galaxies made not of hydrogen and helium, but of antihydrogen and antihelium? Could stars out there be burning with antiprotons in their cores, radiating light just like ours? You drift through that possibility, softly because if matter and antimatter were created equally in the beginning, why would all the antimatter simply vanish? Maybe it did, single quotes. Maybe in some quiet region of space, separated by time and distance, antimatter found itself in enough numbers to form stars, and from stars, galaxies, a mirror, cosmos, shining just like ours, but untouchable, because the border between matter and antimatter is lined with fire. For if such a galaxy ever touched ours, if even a drifting atom crossed paths, the collision would produce gamma rays, powerful flashes of light from mutual annihilation. This is where the search begins, not with sight, but with listening. We turn our eyes to gamma ray telescopes, like Fermi orbiting Earth, scanning the sky for bursts of light that do not match stars, do not match galaxies, do not match anything we know. A gamma ray is a message. It says something vanished and left light behind, and so we listen for messages without senders. Physicists look for asymmetries in cosmic rays, high-energy particles that reach Earth from far beyond the solar system. Every now and then, they find positrons, antiparticles of electrons, traveling through space. Are these the byproducts of strange stars, or just collisions between ordinary particles in high-energy regions? The sky gives no easy answer. Still, we look. We peer into the cosmic microwave background, the afterglow of the Big Bang, searching for subtle fingerprints that might hint at antimatter boundaries, places where annihilation painted the sky with light long gone cold. But we find no such walls, no seams, only smoothness, and still we wonder, because absence is not the same as certainty. Just because we haven't found an antimatter galaxy doesn't mean none exist. They could be far, isolated, surrounded by antimatter gas, never touching the matter-filled universe we know, we imagine, then, what such a place would be like. Its stars would shine just the same. Photons, after all, do not care what birthed them. Light is light. If you stood on an anti-earth, under anti-sky, your body made of anti-atoms, you would feel no difference. The chemistry, the physics, the breath of being, it would all feel familiar, until you reached out and touched a flower from our side. Then both would vanish in a flash of light, and in that light the truth would be told. You sit with this thought: perhaps the universe is divided gently, with antimatter sealed far away, never brushing against us. Or perhaps we are alone, not as beings, but as matter. Maybe the asymmetry of the early universe left no place for antimatter to gather. Maybe the imbalance wasn't just small, maybe it was complete. So we search for signs, we listen for antihelium, heavier than positrons, harder to fake. If found, it would be a strong signal that somewhere antimatter is forming structures. So far, only silence. The alpha magnetic spectrometer, riding aboard the International Space Station, keeps watch, counting particles, sorting them. Looking for ghosts, it has seen hints, teasing possibilities, but nothing that stays, nothing confirmed. Still, the idea lingers, because we have only touched a small part of the sky. Our instruments are still learning to hear. Our models still hum with uncertainty. You think now of the vastness, billions of galaxies, each with billions of stars, and you realize we have looked so little. The quiet between stars could hold anything, and so we imagine, not just out of hope, but out of discipline. Science asks not only what is, but what could be, and in the space between answers, curiosity becomes light. You drift now into the domain of speculation, not fiction, not fantasy, but structured wondering. Could it be that antimatter forms galaxies just like matter? And if so, could they evolve? Could there be anti-life, anti-cells, anti-thought? It sounds wild, but chemically there is nothing that forbids it. An anti-carbon atom would bond with anti-hydrogen the same way. The periodic table, written backward, still spells complexity, still builds chains, still forms patterns, still sings. So the question becomes one not of possibility, but of contact. If such places exist, how would we ever know? We cannot go, we cannot touch. Even the probes we send are made of matter. And so we listen for the only message that can cross safely. Light, photons, born from antimatter stars, would look no different. So we look for the context, for collisions, for boundaries, for gamma-ray halos around galaxies that suggest mixing. So far we see none, and still we look, because the universe is not only vast, it is patient, and we must be. To dot the search for antimatter galaxies is a search for symmetry, not mathematical, but emotional. We want to know if the other side of the mirror ever got the chance to grow, because if it did, then our universe is not lonely, just divided, and if it didn't, then the sliver of matter that remained is all the more precious. A miracle of imbalance. You float now in the silence between galaxies. The cosmic web stretches out, threads of matter connecting luminous nodes. Dark energy moves between them. Dark matter binds them. And in this lattice, we wonder, is there an antinode, a reflection in reverse, a light we have not yet learned to name? You breathe deeply, holding that question not as a burden, but as a candle. Curiosity does not need answers to burn. It glows quietly, warming the space where wonder sleeps. The sky above you remains wide and dark. The instruments remain pointed upward, and softly you ask. You return now, not to the stars, but to a mind, not a chamber filled with magnets, not a telescope staring into the void, but a desk, a pen, a silence filled with symbols. Because before antimatter was made, before it was found, before it flickered in a detector, it was imagined, not from fiction, but from reason, from lines of mathematics that curved toward possibility. You are sitting now beside Paul Dirac, a young physicist in the 1920s, soft-spoken, introspective, more comfortable with equations than conversation. He does not set out to invent another world. He sets out to reconcile two great ideas: quantum mechanics and special relativity, the behavior of particles and the speed of light. Each works alone, each speaks truth, but together they resist. Dirac leans into that resistance. He writes an equation for the electron, a particle well known by then. His equation is elegant, precise, balanced, and yet, when solved, it reveals something strange. Two answers, not just the expected energy of the electron, but a mirror energy, equal in mass, but with opposite sign, a negative energy, something that should not be. Physicists had seen such puzzles before and often ignored them. They dismissed negative solutions as unphysical, mathematical flukes. But Dirac did not. He looked at the mirror and asked, what if it's real? What if this second solution is not a mistake, but a clue? What if there exists a particle like the electron, same mass, opposite charge, an anti-electron, a positron? Dirac proposed it gently. Reluctantly, mathematically, he didn't name it. He didn't know what it meant, but he saw it, a shadow in the symmetry, and so, a decade before it was found, antimatter entered the world, not through collision, but through thought. You linger with this idea, that the universe gave no obvious sin, that nature did not announce her hidden twin, but a human mind remembered what reality had forgotten. You follow now the trail of discovery in 1932. Carl Anderson studies cosmic rays, high-energy particles from space as they pass through a cloud chamber. He sees a track, a curve left behind by a particle. It bends the wrong way, too light for a proton, too heavy for an electron, but just right to be a positron. He doesn't know it yet, but he has found what Dirac imagined. The positron exists. The antimatter counterpart of the electron is not just an idea. It leaves a mark. It speaks in spirals. And with that discovery, a door opens. You walk through it now, into decades of minds that follow where Dirac began. Physicists begin to look not just for the particles they know, but for their reflections. And one by one, they find them. Antiprotons, antineutrons, antideuterium, each a validation, each a soft echo of an idea once doubted. You drift beside the theorists who dreamed ahead of data, who trusted the math when the instruments were silent. They remind you, science is not built only from experiments. It is built from insight, from the stillness where imagination meets rigor. You return to Dirac. He once described beauty as a guiding principle in physics. If one is working from the point of view of getting beauty in one's equations, he said, and if one has really a sound insight, one is on a sure line of progress. Beauty, not decoration, but symmetry, balance. Surprise, that the universe might obey an internal aesthetic, that truth might also be lovely. Dirac's equation is still taught today, still revered, not because it worked, but because it revealed, because it whispered what nature herself kept hidden. You pause now, thinking of all the other discoveries that began as thought. Einstein's time, before clocks confirmed it, bore single quotes as atoms, before spectra sang it. Heisenberg's uncertainty, before experiments danced with it, and Dirac's mirror, before a chamber caught the trail. The human mind is not just a receiver of facts, it is a maker of patterns, a finder of echoes, a weaver of what dash if dot, and in the case of antimatter, that weaving preceded the thread. You drift to the present. Modern physicists build upon these imaginations. They construct vast models, the Standard Model, supersymmetry, string theory, each born in minds willing to believe that the unseen might be real. Theorists run simulations, write matrices, spin up multiverses in chalk and code. They explore not only what exists, but what could have existed, what still might, and all the while, they carry the memory of Dirac's bold question. You feel it now like a heartbeat. What if the impossible is just the unasked? You sit now at a blank page, the silence before the equation, the pause before the symbol. This is where all remembering begins. Science is a memory not just of data, but of potential and antimatter. Though rare, though hidden, is remembered. In every textbook, every lab, every particle tracked with care, we have not found galaxies of it. We have not used it to fuel our ships, but we remember, we hold it in traps, we shape it in theories, we listen for it in the stars. Because once, a quiet mind saw symmetry break and did not look away. You think now of the power of imagining the missing, how poets do it, how artists do it, how scientists do it. They hold space for what the world forgets. They write down what doesn't yet exist. And sometimes the world answers back. You rest inside this idea. That thought itself can be a form of memory, that ideas can hold what nature lets go, and softly you wonder. There is a kind of silence that is not emptiness, but echo, not the absence of sound, but the memory of what was meant to be. You are standing now at the edge of that silence, not in a lab, not in the stars, but in the soft space between knowing and not. The story of antimatter does not end with an explosion, a galaxy, or a breakthrough. It ends here, in the space it left behind. You feel it everywhere, not by its presence, but by its shape. It is the shape of imbalance, the asymmetry that allows your atoms to exist, your breath to form, your world to be solid, because once, long ago, there were two in equal measure, matter and antimatter, twins, dancers, opposites, and yet only one remained, not completely, not without trace, but enough that everything else could unfold. Stars, clouds, planets, you drift now through the aftermath of that ancient mystery, a moment when for every billion pairs that met and vanished, one particle of matter was left, over just one, and that one was enough. That tiny fraction became the seed of galaxies. It became the visible universe. Everything you've ever known exists because of what did not disappear, but just as powerfully. Everything exists because of what did dot the vanished, the missing, the echo. You think now of loss, not as destruction, but as permission. The universe gave up half of itself to make space for form. Annihilation was also a beginning. Without that imbalance, there would be no matter to wonder at all. And so you wonder still. Why did it happen? Why did one remain while the other vanished? Physics still asks. We study CP violation, subtle asymmetries in how particles decay. We probe the standard model, testing its parameters, searching for an explanation written into its bones. We build new theories, supersymmetry, quantum loops with answers in the margins, and still no one knows. The echo remains, but the voice that made it is gone. You walk now through what that means. In science, mystery is not a wall. It is a window. It opens slowly, revealing not just facts, but the questions we are brave enough to carry. The universe did not have to leave clues, and yet it did, in gamma rays, in the curves of tracks, in chambers of mist, in equations that whisper symmetry and then break it just slightly. Each clue a fragment, each fragment a mirror shard reflecting something that isn't here anymore. You feel the power of that reflection, the beauty of knowing that something can be real even if it is rare, even if it is brief, even if it vanishes the moment. It touches the world. You understand now that science is not only about what we see, it is also about what we feel missing, what we know should be there but isn't. Like silence after a melody, like a shadow with no body. Antimatter is that shadow, not haunting, not cold, just unfolded elsewhere. You sit with this absence, and slowly you begin to see it everywhere, in the way your hand does not vanish when it touches air, in the way stars do not flare into photons every time their atoms brush in the way. The universe is calm, stable, safe, because its twin is not here, or if it is hiding so well that even the best minds, the sharpest instruments, have not caught its breath. And maybe that's the point. Maybe antimatter is not gone, just elsewhere in possibility, in memory, in mathematics. You return now to Dirac's equation, its negative solution, its strange beauty. It told us the mirror was there, and now, even as we search for what's missing, we carry that mirror within our thought. Every time we trap a positron, every time we track an antiproton, we are touching a version of the universe that could have been. Every flicker of antimatter reminds us that things might have gone another way, that you might not have been here, that the world might have vanished in light before it ever began, and yet you are here. Matter won, but it did not do so cleanly. It did not erase its twin without a trace. The echo lingers in physics, in poetry, in the way absence can define a shape as clearly as presence. You look now at your own body, built from atoms, held together by the same forces that could just as easily have destroyed it, and you understand something new, that even in victory, matter is haunted, not with fear, but with reverence. It knows what was given up for it to be, what was lost so it could remain, and so you carry that memory too, not as a burden, not as a puzzle, but as a kind of lullaby, a soft refrain whispered from the edges of creation. You are here because something else is not. You float now in that thought. It does not need solving. It does not need fixing. It only needs to be honored. And as your eyes grow heavy, you listen once more to the silence between stars, a silence shaped by echoes of particles that vanished before time began, and gently, almost like a question, you think,